Hi, how is it going? I am Dua Amjad. Today I am going to be talking about large language models. Don't know what those are? I am a Google developer and today I am going to teach you everything you need to know about LLMs. That's short for large language models. In this course, you are going to learn to define large language models, describe LLM use cases, explain prompt tuning, and describe Google's generative AI development tools. Let's get into it. Large language models or LLMs are a subset of deep learning. To find out more about deep learning, check out our Introduction to Gen AI course video. LLMs and generative AI intersect, and they are part of deep learning. Another area of AI you may be hearing a lot about is generative AI. This is a type of artificial intelligence that can produce new content, including text, images, videos, audios, and synthetic data. Alright, back to LLMs. So, what are large language models? Large language models refer to large model purposes, like language models that can be pre trained and then fine tuned for specific purposes. What do pre trained and fine tuned means? Great question. So let's dive into it. Imagine training a dog. Often you train your dog basic commands such as sit down, come here, and stay. These commands are normally sufficient for everyday life and help your dog become a good citizen. Good job. But if you need a special service dog, such as a police dog, a guide dog, or a hunting dog, you add special trainings, right? Like special trainings include training a dog. For example, if it's a hunting dog or police dog, for police dog, it should have this strong effectiveness of smell. Like if a police want to caught a thief, it gives something of a thief so that the dog become able to chase it. So this includes in special training. This similar idea applies to large language models. These models are trained for general purposes to solve common language problems as text classification, question answering, document summarization, and text generation across industries. The models can then be tailored to solve specific problems in different fields, such as retail, finance, and entertainment, using a relatively small size of field datasets. So now that you have got that down, let's further break down the concept into three major features of LLM models. We will start with the word large, like why language models are called as large language models. Basically, large indicates two meanings. First is the enormous size of the training datasets, sometimes at the petabytes scale. Second, it refers to the parameter count. In machine learning, the parameters are often called as hyperparameters. Parameters are basically the memories and the knowledge that the machine learned from the model training. Parameters define the skill of a model in solving a specific problem, such as predicting text. So that's why we use the word large. What about general purpose? General purpose is when the models are sufficient to solve common problems. Two reasons led to this idea. First is the commonality of human language, regardless of the specific task. And second is the resource restriction. Only certain organizations have the capability to train such large language models with huge datasets and a tremendous number of parameters. How about letting them create fundamental language models for others to use? So, this leaves us with our last term pre trained and fine tuned, which mean To pre train a large language model for a specific purpose with a large data set and then fine tune it for specific aims with a smaller data set. So now that we have nailed down the definition of what large language model or LLMs are, we can move on describing LLM use cases. The benefits of using large language models are straightforward. First, a single model can be used for different tasks. This is a dream which comes true. These large language models that are trained with petabytes of data and generate billions of parameters are smart enough to solve different tasks, including language translation, sentence completion, text classification, question answering, and many more. Second, large language models require minimal field training data when you tailor them to solve your specific problem. Large language models obtain decent performance even with little domain training data. In other words, they can be used for few shot or even zero shot scenarios. In machine learning, few shots refers to training a model with minimal data, and zero shot implies that a model can recognize things that have not explicitly been taught in the training before. Third, the performance of large language models is continuously growing. When you add more data and parameters, large language models are mostly exclusively based on transformer models. Let me explain what that means. A transformer model consists of an encoder and a decoder. The encoder encodes the input sequence and passes it to the decoder, which learns how to decode the representations for a relevant task. We have come a long way from traditional programming to neural networks to generative models. In traditional programming, we used to have a hard code, the rules for distinguishing a cat. For example, type animal, legs, 4 ears, two, fur, yes or no, likes yarn, and catnip. In the wave of neural networks, we could give the network pictures of cats and dogs and ask, is this a cat? And would it predict a cat? What's really cool is that in the generative wave, we as users can create our own content, whether it be text, images, audios, videos, or many more. For example, models like Gemini, Google's multimodal AI model, or Lambda, language model for dialogue applications ingest very large data from multiple sources across the internet and build foundation language models we can use simply by asking a question, whether typing it into a prompt or verbally talking into the prompt itself. So, when you ask it, what is it a cat? It can give you everything it has learned about a cat. Let's compare LLM development using pre trained models with traditional ML development. First, with LLM development, you don't need to be an expert. You don't need training examples, and there is no need to train a model. All you need to do is think about prompt design, which is a process of creating a prompt that is clear, concise, and informative. It is an important part of natural language processing, or NLP for short. In traditional machine learning, you need expertise, training examples, compute time, and hardware. That's a lot. More requirements than LLM development. Let's take a look at an example of a text generation use case to really drive the point home. Question answering or QA is a subfield of natural language processing that deals with the task of automatically answering questions posed in natural language. Question answers system are large amount of text and code, and they are able to answer a wide range of questions, including factual definitions and options based questions. The key here is that you needed domain knowledge to develop these answering models. Let's make this clear with a real world example. Domain knowledge is required to develop a question answering model for customer IT support or healthcare or supply chain. But using generative QA, the model generates free text directly based on the context. There is no need for domain knowledge. Let me show you a few examples of how cool this is. Let's look at three questions given to the Gemini, a large language model, chatbot developed by Google AI. Question number one given to it is that this year's sales around 1 lakh, expenses are 60,000. How much is net profit? So Gemini first shares how net profit is calculated, then performs the calculations. Then Gemini provides a definition of profit. Here's question. Inventory on hand is 6,000 units. A new order requires 8,000 units. How many units do I need to fill to complete the order? Again, Gemini answers this question by performing the calculation. At our last example, we have 1,000 sensors in 10 geographic regions. How many sensors do we have on average in each region? Gemini answers the questions with an example on how to solve the problem and some additional context. So, how is that? In each of our questions, a desired response was obtained. This is due to prompt design. Fancy. Prompt design and prompt engineering are two closely related concepts in natural language processing. Both involve the process of creating a prompt that is clear, concise, and informative, but there are some key differences between the two. Prompt design is the process of creating a prompt that is tailored to the specific task that the system is being asked to perform. And whereas prompt engineering is the way of texting, simply. Okay, this is all for today. Hope so you guys understood LLMs and basic concepts and know how these models work out. Thank you a lot for listening. If you have any question or queries, inform me in the comment section so that I can respond.